so we're working through the applications of the ideal gas law, PV equals nRT. We're ready to look at part 2. In part 2, we are going to see that PV equals nRT is a tool to obtain one of those variables if you know the other 3. Okay, so that's what we're going to work through here. So this is what the application says. If you're given 3 of the variables, you can determine the 4th. Now let's write PV equals nRT down. PV equals nRT. It looks like there's 5 things, but remember, this is a constant. It is not a variable. The variables are P, V, N, and T. So we know we're dealing with a gas. That's the equation we pull out for a gas. If we know the temperature and the volume and the pressure, need to know moles, this is a way to get to moles. Given the 3, we solve for the 4th. If we know the number of moles and the temperature, and we want to know what volume that gas occupies, as long as I knew the P as well, I could solve for volume. So anytime I have a gas and I know 3 of the things, and I need the 4th for some reason, I know I can pull this equation out. So let's work through some problems, okay? As I look at this one, there's a lot of wording, so it might be a really good idea to pause the video and you yourself read through it and see what's given and what you're trying to solve for. Then come back. Okay, hopefully you did that. So I read through there and I see conditions of a cylinder. It can withstand 500 atmospheres of pressure, and it tells me this cylinder is a 4.5 liter cylinder. So it's a gas cylinder. Let's draw a little picture. Gas cylinder. It's got a little valve on it that I can hook up, and this is a 4.5 liter container. And once it gets up to 500 atmospheres, it has a risk of exploding, all right? So that would be really bad. We wouldn't want that to happen, okay? So we don't want the pressure to exceed that. Now it tells me that this is what I have in this cylinder. It contains in this cylinder 42.0 moles of gas, okay? It tells me it's 24 degrees Celsius, okay? And from that, it wants to know, is it on the verge of exploding? In other words, what does it want us to find? It wants us to find, because we know that at 500 atmospheres, boom, all right, 500 atmospheres it's going to explode. Is it going to explode? So what we want to know is, what's the pressure? Now, at first glance, you might say, well, it gives me one pressure and it's asking for another pressure. Maybe this is a change, but it's not changing. It's just saying I have a cylinder, it's this big, it has this many moles, it has this temperature, tell me, will it explode? In other words, what's the pressure? So we're going to solve this equation here for pressure. So pressure equals nRT over volume. Now we'll plug in everything we know. Number of moles, 42.0 moles. Now watch how I write those units down. Don't be lazy, do it. R, 0.08206 liter atmosphere. This is what people don't want to write down because it takes a little time per mole Kelvin, okay? But as soon as I write that K down, it will remind me, don't leave it in Celsius. Make sure you convert it to Kelvin. So it's 273, and since I've got decimal places here, I'm going to go ahead and use the 0.15 there as well. And then I divide by the volume they gave me, which is a 4.5 liter container. Take the time to make sure your units cancel. A mole and a mole. Notice how this is on top and this is on bottom. A Kelvin, a Kelvin. A liter, we're left with atmospheres. So when we put that all into our calculator, we're going to get 228 atmospheres. That's a lot of pressure, but it is not up here to the 500, so it is not likely to explode. Now, something I'm not going to do with you here, but something you might want to consider is, well, what temperature do I have to get it up to so that it would explode, okay? Because you read the temperature. As the temperature goes up, the pressure is going to go up because the volume's not changing. As the temperature goes up, the pressure goes up. As the temperature goes up, the pressure goes up. Eventually, the temperature is going to get so high that it's going to exceed that 500. So that might be just an exercise that you'd like to try. What temperature will give you a pressure of 500 atmospheres? If you want to come and see me and see whether you did it correct, I'll be happy to go over that with you. Okay, so that's our first example of using PV equals nRT in order to figure out one condition when I knew 3 of the 4 variables. Now it's time for you to try one. I want you to read through this problem, and I want you to pick one of those answers as a correct answer to this. Once you've selected one, because you worked through the problem carefully, then resume the video. Okay, you're back with me. Did you select number 1? If you did, you're correct. Okay? If you're correct and you feel real comfortable about your work, you're done watching this video. If you didn't pick number 1, the common mistakes that I know people make is in number 2, you might not have used the formula of N2 for nitrogen. We got to remember that nitrogen is one of our diatomic molecules. Remember Hofbrinkel? It tells us which elements are diatomic. So if it's nitrogen gas, it doesn't exist as just N, it's N2, and we'll have to use a molar mass of that. Maybe you selected number 4. You did the N2 part right, but you forgot that you've got to use Kelvin, and you might have selected 15.8 if you did that. Look through your work, see if you can find your mistake, and if you feel comfortable that you found it and you won't make that one again, you're done watching this video and you can move on. But I am going to go ahead and work this problem for you so we can make sure that we feel really comfortable, for those of you feeling a little shaky still, about using this and getting this answer. So I see here that I am trying to calculate the pressure of a gas, and I know that PV equals nRT will help me get the pressure of the gas, as long as I know everything else in this equation. So let's go through and see if we do know everything else. Was volume given to me? Yes, they gave me volume. It is 4.0 liters. Okay. Is moles given to me? No. Moles is not given to me, but they did give me grams, and when I was given grams, I can get to moles, so I'll be able to get to moles. R, well, we always know what R is, no big deal there. And temperature, they gave me a temperature, yes. Now, we don't use a 200 degrees Celsius, right? 200 degrees Celsius plus a 273 will give me 473 Kelvin. That's what we want to use. So let's solve for pressure. Pressure equals nRT over V, and let's plug everything in. Oh, I can't plug everything in because I don't know N yet. So let's come over here to the side here, and let's take the grams. 25.0 grams. I don't, and this is grams of what? Let's be specific. This is grams of N2. I don't want grams of N2. I want moles of N2. Okay, so I go to my periodic table, and I remember that it's 2 nitrogens, so each nitrogen is 14.01, so that's 28.02, and that goes with the grams per mole. This is going to give me 0.862 moles of N2. Okay, so now I do know the moles of N2 that I can plug into this equation. So let's put that here, 0.862 moles. All right, let's do the next, which is, oops, sorry, here, R, 0.08206 liter atmospheres, don't be lazy, mole Kelvin. Temperature, 473 Kelvin. That doesn't look like 473 to me. Let's try to make it a 7 there. All right, 473 Kelvin. Still doesn't look much like a 7, but there we go. All right, and then we've got our volume that they gave to me, and that was, the container was a 4-liter container. So now let's see what cancels. The moles, definitely, the liters, definitely, the Kelvin, definitely, and we're left with the atmospheres, and that is the 0.66 atmospheres that we should have gotten. Okay, so just to wrap it up, we've got PV equals nRT, where if we know 3 of the variables, we can get the 4th, and we've worked through several problems, and we'll do more in class.